let's take question number 5 here, which says there is a long cylindrical volume that contains a uniformly distributed charge of density rho. So here you have a long cylindrical volume which has charge distributed in it. In the whole volume, and the volume charge density here is rho. So charge is distributed in this big cylinder with a volume charge density rho, charge per unit volume. Find electric field at a point P inside the cylindrical volume at a distance x from the axis. So if I take this as the axis, at a distance x from the axis, we have a point P. We need electric field at point P. So we are looking for electric field at point P at a distance x. What should be the step? Obviously, it is not a case of electric field due to a line charge distribution. It is a different situation where I have to find electric field at a point P inside. So we follow those basic steps of Gauss theorem application. Step 1. Assume a Gaussian surface such that point P lies on it, and preferably the shape of the Gaussian surface should be same as that of the source charge. So I assume here a Gaussian surface which is a cylinder of radius x. So we have assumed a Gaussian surface which is a cylinder of radius x. Point P lies on it. It has the radius x only. Look for the direction of electric field. So if I say in what direction the electric field will exist, electric field will be outward. Electric field will be normally outward. Find the flux through each kind of surface. So let's find the flux through this part. ds will be here, E will be here. So the flux will be E ds cos 0, and total flux will be E into integration of ds. So the total flux will be E into 2 pi xl, where L can be the length of the cylinder and x is the radius. So this cylinder has got a length L and its radius is x, so its curved surface area is 2 pi xl. Then another point, look for the charge inside. So if I find the charge inside, it will be, what is the volume here? It will be pi x square into L. Pi x square into L. This is the volume of the cylinder. And what is the charge density? Rho. So we know the net flux, we know the charge inside. Let's apply Gauss theorem. So here net flux is what? E into 2 pi xl. And what is charge inside? Pi x square L rho by epsilon naught. Pi gets cancelled, x 1 power gets cancelled, L gets cancelled. So you are having electric field as x rho by 2 epsilon naught. Electric field inside is directly proportional to x. So we can calculate electric field in this situation. It was appearing to be a case of linear charge density or charge distributed in a length, but in fact it was a case of volume charge density. And if I ask you, do you think that this cylinder is made up of conducting material or non-conducting? So our answer should be it has to be non-conducting, because for a conducting material, charge will come at the surface. So these 5 questions were on one concept mainly. Now I take the case of electric field due to spherical shell and electric field and potential due to a sphere which is uniformly charged. So we have some very interesting question on shell and sphere now. So before I take these questions on electric field due to a charged shell, let me repeat what you have learned. In case if you have a charged shell, so obviously the charge resides at the surface only, and this charged shell has got a radius capital R. So when we are looking for the electric field outside, it behaves as though the whole charge is situated at center, maybe at a distance r. So it will be 1 by 4 pi epsilon naught q by r square. And similarly for the potential it will be 1 by 4 pi epsilon naught q by r. And then if we say what is the electric field and potential at the surface? So again for the surface it behaves as though the whole charge is situated at center. So the electric field will be 1 by 4 pi epsilon naught q by capital R square, or potential will be 1 by 4 pi epsilon naught q by r. But then comes within. So if we are looking within, the electric field within the shell is 0, and the electric field within the shell has a value V everywhere. Now question is, what is that V? So this V is actually having the same value, 1 by 4 pi epsilon naught q by r. It is the same potential which exists everywhere within the shell. There is another concept that we will be discussing here, and it's about, just imagine you have a shell, and this shell has a charge capital Q. This shell has a charge, say, capital Q. And assume that here you have introduced some other shell inside, or it may be a inside, maybe a sphere or maybe a shell, doesn't matter. And say it has a charge Q distributed on it. The charge which is distributed on it is small q. Now in this case, if it has a charge small q, then there will be something called induced charge. Induced charge always move from in to out. So as a whole, you will have an induced charge, the effect of it on the outer, in onto the inner side minus q and onto the upper side plus q. It means the outer surface will have a net charge which is q plus q, and the inner surface will have a net charge which is minus q, where there will be no effect of this positive plus q charge as induced charge on the inner one. So no induced charge would go inward. Induced charge would always come from in to out. So these two concepts we are going to take in the next 5 questions. So we start with this question number 6, a very interesting question, which says there is a metal sphere of radius A and it has a charge q on it and is surrounded by another shell of radius B and charge capital Q. So I would say there is inside a metal sphere of radius A. It may be a metal sphere, but charge will remain at the surface only. So this metal sphere has a charge Q, total charge Q, and it has got a radius A. And this is surrounded by another shell of radius B, and it has a charge capital Q on it. So the charge which is on the outer shell. It has to be shell, then only we can accommodate a sphere inside. It has a charge q on it. Question is, find the net potential on the inner shell or on the inner sphere and find the potential on the outer sphere. So first part of the question says, find potential difference between the sphere and the shell. So I'll just first take first part of the question and then I'm coming to the next part of the question. So if I take first part of the question, I want what is the potential on inner shell or inner. Okay, let's take first on outer shell. On outer shell. There are two reasons for the potential on outer shell. One is potential on the outer shell due to its own. And second, potential due to inner sphere. Now if I ask you, it has got a charge q, it has a radius b, how much will be the potential on outer? It will behave as though the whole charge is situated at center, 1 by 4 pi epsilon naught q by b. This is the potential on the outer shell due to charge on its own. And you know, it will behave as though the whole charge is situated, if plus q was assumed to be here, what will be the potential here? 1 by 4 pi epsilon naught capital Q by b. Similarly, for the outer point, for a point here, what will be the potential by this small q? So you will assume as though the small q is here. If small q is here, how much will be the potential due to its at the outer surface? It will be 1 by 4 pi epsilon naught small q by b. So I am finally having the potential on the outer shell, which is 1 by 4 pi epsilon naught q by b, 1 by 4 pi epsilon naught, and it is 1 by b or q plus q by b. This is the potential on the outer shell. Now let's take what will be the potential on inner shell. Potential on inner shell or inner sphere. So if I am looking for the potential on this inner sphere, there are two reasons. One is, you will assume due to its own. So potential on the inner sphere includes due to own plus potential due to outer shell. Now if I say how much will be the potential due to its own, it will assume as though the whole charge is situated at center at a distance, say the potential will be 1 by 4 pi epsilon naught q by a. So due to its own, the potential will be 1 by 4 pi epsilon naught q by a. And as far as the potential due to outer shell is concerned, you know, if the potential here is V of the outer shell, if potential here is V of the outer shell, then same potential would come in. So potential of the outer shell was this, 1 by 4 pi epsilon naught q by b. The same potential of the outer shell would also exist everywhere inside. So here the potential on the inner shell will become 1 by 4 pi epsilon naught q by a plus Q by B. You can see the difference between these two equations. Here it was capital Q by B plus small q by B. Here it is small q by A plus capital Q by B. So if we are looking for potential difference, where the potential will be higher, let's try to find. It is Q by B plus small q by B, but here it is small q by A plus capital Q by B. A is less than B. So we can say potential on the inner shell, as we can see, will be higher than the potential on outer shell. And how much will be the potential difference? That potential difference between the inner shell and outer shell can be written as V inner minus V outer. And if I do first minus second, we are getting that potential difference as 1 by 4 pi epsilon naught small q 1 by A minus 1 by B. So we are getting a potential difference between the inner shell and the outer shell, and that potential difference is 1 by 4 pi epsilon naught q 1 by A minus 1 by B. The inner shell is at a higher potential as compared to the outer shell. Now, the other part of the question comes. And that other part of the question, if you are looking back, it was also state why the whole charge of the sphere will be shifted to shell in case if the two are connected by the wire. So I am just making those two situations again. The inner one was having a charge Q, was having a radius A. The outer one was having a charge capital Q and was having a radius B. The potential difference, the potential of inner minus potential of outer, is 1 by 4 pi epsilon naught Q 1 by A minus 1 by B. Inner is at a higher potential than outer. What will happen if the two are connected by a wire? So if I connect the two by a wire, what will happen? When you connect the two by wire, the charge will flow from higher potential to lower potential until the potential is same on both. The charge has a tendency to always have a flow from higher potential to lower potential until the potential is same on both the surface. Now question is, yes, the charge will flow from inner shell to outer shell. And in what condition there will be same potential on both? So, you want V inner to be equal to V outer. A is fixed. It is the radius of inner sphere. B is fixed. It is the radius of the shell. Nothing can be done about them. The only variable on the right side is small q. So for small q is equal to 0, V inner will be equal to V outer. It means the whole charge, until this whole charge small q is shifted to the outside, the charge will flow. And once there is no charge here left, then only the potential on inner will be equal to potential on outer, and then only the flow of charge will stop. So the outcome is, the result is, that whenever you have a charged sphere inside, surrounded by outer shell, the charge for any value of charge on the inner sphere, the potential on the inner will be higher than the outer. And if the two are connected by a wire, then charge will fully flow from inner to outer until there is net charge inside 0. So until and unless the whole charge shift from the inner to outer, the charge would flow and that's why no charge will remain inside.